So the technique is public. The key is secret. And I told you this is called a symmetric, if I can spell symmetric, good grief, symmetric key. We call this a symmetric key system. It does have some weaknesses. Okay? The first one is the keys have to be distributed secretly. So if I'm talking about my friend in class, I have to go to him at the beginning of class, or her, and say, here's the key for today. And then so we have to keep it a secret. We have to do it outside of the normal channel. Okay. The second weakness here is there is lots of traffic encrypted with that key. That means if the key gets broken, somebody has access to all of our communication. All right? The other thing about it is, if I keep the key stable, so we call that a static key, and we'll worry about that in a little bit too. That one will stay the same always. Okay? So if I told my friend our key is always cab, and it's cab every day, every day, every day, every day, eventually my teacher is going to get so much communication from us by taking the notes from us in class or picking them out of the trash, I don't know, that they'll be able to actually go through and do their frequency count, and it will show, here are the probabilities of which ones are going to be E's. And then they can go through and actually hack it and break the thing. So a static key is one that stays the same all the time. And again, we worry here, there's so much traffic with one key that if someone ever gets a hold of the key, that's a lot of traffic they can decrypt. And the last thing, sorry, it didn't fit on the page. Did y'all write that one down? Are you good? So a static key stays the same always. The last weakness is that every partner needs a separate key. So imagine if it's kids in class, right? And there's for symmetric keys. So this is symmetric keys. Static keys is just being in that it stays the same. This is still symmetric keys. So with the symmetric key, if we have, here's a very small class of 9 kids. Right? I need a key to talk to this person. I need a key to talk to this person. I need a key to talk to this person. I need a key for every person I talk to. Okay? The next person needs a different key than mine for every person they talk to. Isn't this fun? So this would be like key number 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay? Eventually we get halfway through the class and then it works okay. Oops, I went all the way to 9. Sorry, it's only to 8. Anyway, you need a lot of keys. Let's just leave it that way. So we need all these keys to connect everyone together, and eventually it just gets to be a big hassle. All right. And so now we'll talk about the next thing. Where is that? You do have a separate option, and they call this one public key encryption. All right? This is different. We just talked about symmetric key encryption. This one is called public key. With public key encryption, each person has 2 keys. Okay? One is public. That is, they can share it. And one is private, which is going to be a secret. Okay? These are also really long keys, okay? These are 128 bits long kind of thing. All right, I'm not going to tell you what how the math of this works, because it is a big pain. And even to do like one number or one letter encryption is a huge pain. But the bottom line on this is they are different. Okay? They end up being different numbers. If you know someone's public key, it doesn't mean you can figure out the private key. We'll just put we can't, we'll put figure out. Okay. Are we good here? So the idea here is I can share this key publicly, and then no one will know my private key. The second feature is a message encrypted with the private key. I'm going to have to extend this. So if I encrypt a message with the private key, it can only be decrypted by the public key. Decrypted by the public key. That's crazy. Right? It also works vice versa. So what happens here is here I am, Alice, and I'm talking to Bob, and I have my private, and I have Bob's public. All right, oops, I'll go down. You guys getting this written down, what you need? So here's Alice. Okay. Bob has Bob's private, and they have Alice's public. Right? So remember, the public I can share all I want. The private I keep secret. All right? So Bob here shared his public key with Alice. Alice shared her public key with Bob. Now, can you guys look at this? If I'm Alice and I want to send a message to Bob that no one else would be able to decrypt except Bob, what key do I use to encrypt something? If I want to send something to Bob, I use Bob's public. Y'all see that? If I encrypt something using Bob's public key, who can decrypt it? Only Bob, because you have to have that private key that goes together. Right? So I can encrypt with the public key, send it to Bob, and that's a decrypt. Right? And if Bob wants to send a message to Alice, it goes here and we encrypt, and then it goes the rest of the way, and Alice can decrypt it. Are we good here? I'm going to put in Emily for my third person. Remember we were complaining about having to have a separate set of keys for everybody? So Emily has her private key, and she can have Alice's public and Bob's public. Okay? And in fact, she can just ask Alice for her public key anytime she wants. But notice here, Emily can now communicate with Alice and with Bob. No problem. We don't have to have all those zillion keys like we did up here. Okay? Or all this stuff we have to keep track of. Following here? So all I gotta know is, I'm Emily, I'm sending something to Bob. Hey Bob, what's your public key? Here's your message. And then Emily knows only Bob can decrypt it.
And so if they use the private key to encrypt, then anyone could decrypt.
Right, so if Alice uses her private key to encrypt a message, then anyone can decrypt it. But it does do one thing. It proves that it can prove that the message came from Alice. Does that make sense? We'll see later what we can do with